Welcome to e-learning. This time it's about levels, advanced and applied, part 1. If you for one reason or the other are not familiar with levels, look at the video called Levels, the Basics. The aim is that you learn how to check a gradient, to find a distance from a well to a connection point on a plot, to find a bottom level of a connection point. And the plot we are using is the plot you know that lies in Utterslev Mose. Let's take a look at the plot at Utterslev Mose before we start the calculations. Here lies plot 10, here lies well S10, and here lies the bottom level of the well S10. Here lies well S24, and here lies the bottom level of well S24. Here lies the southwest corner of plot 10. Here's the road where the main sewage line runs. Let's take a look at the exercise. As mentioned, we are building at plot number 10, and the sewage pipe is 5.2 meters east from the southwest corner of the plot. The pipe is 110 millimeters PVC. Furthermore, we are giving some information about measured distances. The distance between well S10 and well S24 is measured to 103.0 meter, and the distance from well S10 to the southwest corner is measured to 31.32 meter. The first exercise we have to do, or the first calculation, is to do a check on the gradient that is stated on the drawing, and we do that by finding the difference in height between well S24 and well S10, and we give the result with 1 decimal because the gradient of the line is under 10 promille. Taking a look again at the plot, you can see that the gradient that is stated is 4 promille, and that's the one we have to check if it is right. So let's start with checking the gradient as given in the exercise, and we start with sketching a model and filling in the values we are given. I have now sketched up the model, and the gradient, that's the one we're going to find, and you can see here's S10, the well S10, and here's the well S24, and the well S24 lies higher up because the bottom level is a bigger number than what we have for S10. Here's the length, it is giving us 103.0 meter, and here's the height, and we can find the difference in height by subtracting the two levels. I have found the difference in heights, and it is equal to 0.400 meter. Furthermore, I have written up the well-known formula for finding gradient, that equals height divided by length. And now we just have to fill in the values. I've been filling in the values in the formula, and here's the gradient stated in decimal form, and let's give it in promille. It is 3.9 promille. Remember, we give the promille with 1 decimal when it's under 10. Let's check with the promille given on the plot. It is 4, and we got 3.9, and that is the reason why we always check things. Next thing we have to do is to find the distance from the well S10 to the connection point, and we have to give the result with 2 decimals. As before, we sketch a model and fill in with the information we have. I have now sketched a model. Here lies well S10, and here's the bottom level of well S10. Here lies well S24, and here's the bottom level of well S24. Here lies the distance from well S10 to the southwest corner of plot 10, and that is given in the exercise to be 31.32 meter. Here lies the southwest corner of plot 10, and the distance going east is given as 5.2 meter. In order to find the distance from the well to the connection point, you have to add this to the distance going east. And that means you add up 31.32 plus 5.2 meter, and that equals 36.52 meter. The next thing we have to do is to find the bottom level of the connection point, and it has to be given with 3 decimals because the gradient of the line is under 10 promille. Again, I'm going to sketch up a model to help me with the calculations. I have now sketched up the model. Here lies the well S10, and here lies the connection point. Here's the gradient we found to be 3.9 promille, and here's the length we just calculated. So we have to find the height, and that is the height difference between well S10 and the connection point. We use the formula height equals length times gradient, and I have already filled in here. So the height equals 36.52 meter times 0.0039, that is the gradient written in a decimal form. So what I get is I get 0.142 meter. To find the level at the connection point, I just add the 0.142 meter to the bottom level of S10, and this is what I have done down here. You can see that the formula is S10 plus the difference in heights. This is the level that is at well S10, and this was the value we just found. So the level at the connection point is going to be 16.188.